Good afternoon to everyone watching. Today we'll be discussing some further Olympiad questions. This is the third level in the series of probability and combinatorics, of course. And these will also be from the Olympiad level, of course, as we have already discussed, which are to appear in the future examinations. Obviously, we'll be having the same set of 5 questions today. But what will be more important today to understand is that we will be exploring a certain problem, which initially is actually elementary. But then going on the course of exploration and intriguing and curiosity towards what can be another answer or what can be another question that you can birth from this question, we will find and explore an amazing theorem which is nowhere to be found. It will only be found in Combinatorics, and it will be a grid theorem. Just to give a little trailer to what we'll be seeing today, the grid theorem for any n by n grid, how many rectangles you can make with the squares not included, right? Okay, so again, the set of 5 questions. Let us go with our first question today. So in our first question, there's a man X who has 7 friends. This man X has 7 friends, 4 ladies and 3 men, right? This is X. His wife Y also has 7 friends, but 3 ladies and 4 men. Now they want to organize a party with 3 ladies and 3 men such that 3 friends of X and 3 friends of Y are invited. It's a very easy and elementary problem. We have discussed multiple examples with these kind where we are actually choosing and making choices from the multiple variation and observations we have to consider. But let us write down the cases which are possible, right? So we have one case in which we can invite 3 male friends, or 3 male friends of X and 3 female friends of Y. This is case 1. Okay. Now 3 male friends of X. How many male friends does X have? X has 3 male friends, right? So that's 3C3. Similarly, how many female friends does Y have? That's 3C3 again, right? So that is going to be 3C3 and 3C is 1. Okay. Now we'll be moving to the second case, which is a little shifted, of course, where you have 3 female friends of X into 3 male friends of Y. Okay. Now X has 4 female friends, right, or 4 ladies, right? So you have to choose 3 from 4, which is 4C3, and into 4C3 again, because over here the lady Y, she has 7 friends of which 4 are male, right? So it'll be 4C3 into 4C3 again, which will give us a value of 16. Okay. Now we'll move to case 3. In case 3, what we can do is, you can invite 2 female friends of the male, right? 2 female friends of the male into 1 male friend, okay, which means of X, into 1 male friend. So 1 male friend of X into, so 2 females and 1 male have been invited, and then you can replace that with the female, where you can invite 1 female friend of Y into 2 male friends of Y. So in this scenario, you require 3 ladies and 3 men, and 3 friends of X and 3 friends of Y. So imagine this event in one bracket where you're inviting the friends of X, 2 female friends out of the 4 female friends he has, and 1 male friend out of the 3 male friends he has. Similarly, in this case, when you're finding the friends of Y, we can do 1 female friend out of the 3 female friends Y has, and 2 men out of the 4 men to consider. Okay. Okay, so 2 female friends out of X's total female friends. Now X has 4 female friends, which is going to be 4C2 multiplied by 1 male friend of X, that is going to be 3C1. Then 1 female friend from Y will also be 3C1, and this will also be 4C2. So 4C2 can be written obviously as 4 factorial by 2 factorial 2 factorial. 3c1 will come out to obviously 3 as we know. And since this is actually repeated, we can just write it as a square for our understanding. So 4 factorial by 2 factorial 2 factorial will be about 6. And 6 into 3 whole square is 18 whole square, which is 324. So the 324 cases in case 3. And then the last and final case where you can invite, let's say, 2 male friends of X. So you're inviting 2 male friends of X into 1 female friend of X, right? Multiplied by, so you have already invited 1 female, so you require 2 female friends of Y or 1 male friend from Y into, this is going to give us 2 female friends of Y, right? So this is another case, which is separating. So this is going to give us now 2 male friends out of how many male friends does X have? He has 3. So 3c2 and 1 female friend out of the 4. So into 4c1. 1 male out of the 4 males, which is 4c1, and then again it will be 3c2, right? So 3c2, as we know, is going to be 3. 4c1 is going to be 4. If we see it's repeated as 144. So when you add all the events, because we can work with either of these events being satisfied for our job to be completed, you will get a total number of 485 total cases. You can do the addition work yourself. There are 485 total cases in which these conditions are met already, where there are 3 ladies and 3 men to be invited in a party, and these 6 people are so distributed that there are 3 friends of X and 3 friends of Y. Okay. Now we'll be taking another easy question from KVPY 2009, which is to some extent not related to probability per se, but maybe throwing in some concepts of algebra and expression of certain terminologies will be helpful, right? But these kind of questions have appeared in KVPY 2009. So just to keep ourselves prepared, so as I said, it's KVPY 2009. Okay, so we have an expression 1 plus 2 raised to x whole raised to 20. 1 plus 2 into x whole raised to 20, which is equal to a0 plus a1x plus a2x square up to a20 x raised to 20. We want to figure out the value of 2a0 plus 3a1 plus 2a2 plus 3a3 up to the value 2a19 plus 3a20. So we are taking 3a0 plus 2a1, 3a0 plus 2a1 plus 3a2 plus 2a3, all up to, we will be getting 2a19 plus 3a20. It's a very easy question, and it just requires a little bit of manipulation by using the values of x. So let us jump right on that. Okay, now let us take the value of x as 1, right? If we take the value of x as 1, we'll be getting 1 plus 2x to be 3, because 2 into x is 1 and is 2, and 2 plus 1 is 3. So we get 3 raised to 20. And over here, since x squared till x20 will all be equal to 1, because 1 raised to any power is 1. So we'll get to know that 3 raised to 20 is equal to a0 plus a1 plus a2 up to a20. This is one equation we have in mind. The second equation we have is, let's take x to be minus 1. Now if x is minus 1, then 2 into minus 1 is going to be minus 2. Minus 2 plus 1 is minus 2 plus 1 is minus 1. So minus 1 raised to 20. Minus 1 raised to 20. Now if you know that minus 1 raised to any even power is 1. So over here we'll be getting 1 equals, now we have to be very mindful because the value of x which we have taken is minus 1. So a0 will remain a0, but a1 will come with a minus sign, then a2 will remain like this. So if you see, all the even subscripts will have a positive signs to accompany them, and the odd subscripts will have a negative sign to accompany them, and at the end we'll be having minus A19 plus A20. Okay, now we want the value of 3A0 plus 2A1 plus 3A2 plus 2A3 till 2A19 plus 3A20. Let's take this sum as S, and we can write this down as, if we can observe over here, 3 into A0 plus A2 plus dot dot till A20, which means all the even subscripts, plus 2 into A1 plus A3 plus A5 up to A19. So we have reduced the sum which we have, the ginormous sum, to a simple expression, and we can look at how we're going to find that expression, right? Okay, let us add these two first. Let us add these two equations. We'll get 3 raised to 20 plus 1 equals, now if you look over here, all the odd subscripts are going to get vanished, because in this first equation they're all in positive, but when you see the second equation, the ones with the odd subscript are negative. So A1 and minus A1, A3 and minus A3 will get cancelled. We'll be left out with 3 raised to 20 plus 1 equals 2 into A0 plus A2 up to A20. From here we can also write that 3 raised to 20 plus 1 whole by 2 equals A0 plus A2 into whole till A20. And we want, for the first part of our summation, 3 into A0 plus A2 plus, which means the even subscripts. Right? Yeah. So we will be multiplying this by 3. So the answer to the first part will be 3 into 3 raised to 20 plus 1 by 2. So we have figured out one part of this. Okay. Now we want to know what will be A1 plus A3 plus A5 up to A90. Let us come to initially making this possible. So 3 into 3 raised to 20 will be 3 raised to 21. And 3 into 1 will be 3. So 3 into 21 plus 3 by 2 is the first part of this equation, this part. Now 2 into A1 plus A3 plus A5 up till A90. Now what we can do is, we only want the odd subscript. So if we somehow subtract these two equations, the 0 and all the even subscripts will be gone, because they're both positive. But this will become 2 into A1 plus 2 into A3 plus 2 into A5 till A19, which is this corresponding to the second part of our equation, our summation over here, right? So therefore we'll be getting 3 raised to 20 minus 1 divided by 2. So because we'll be getting, again, what do we have to get? 2 into, we'll be getting at the end of it, 3 to 20 minus 1 equals 2A1 plus 2A2 plus 2A3. I mean 2A1 plus 2A3 plus 2A5 till A19, and then we require that exact value. So we'll be getting 3 raised to 20 minus 1 as the second part of our summation to be 2A1 plus A3 up to A19. Now we are left to add, right? So our summation, so our final expression will come to is that our summation is equal to 3 raised to 21 plus 3 by 21 plus 3 by 2, right, plus 3 raised to 20 minus 1. Okay, so if we further simplify this, we'll be getting 3 raised to 21 plus 3 plus 2 into 3 raised to 20 minus 2 whole by 2. Okay, now 3 minus 2 is going to give us plus 1 on one side. But now we have 3 raised to 21 plus 2 into 3 raised to 20. If we look at it properly, we can see that 3 raised to 21 can be written as 3 raised to 20 into 3 plus 2. Right? So at the end of this quest of learning, we will get our answer to be 5 into 3 raised to 20 plus 1 by 2. This will be our final answer for this question. Okay. Now, the starting questions which we have taken for now have been very easy and very easily solvable by anyone even in the 8th or 9th grade. Now we will be moving on to questions which require that share of logic necessary for us to understand what is to be done. Okay. So the first kind of question, which is the third question for today, is as so. we have straight lines drawn by joining m points on one line to n points on another line. Okay. We have one line with m points on it and one line with n points on it. Now, we have to find out the total number of intersection points and then prove that the number of these intersection points will be half into mn into m minus 1 into n minus 1. Fair enough. Now, let's come up with a logical approach to this. Let's say this is our line 1 with m points and line 2 with n points. To find out how many intersections there will be, let's say we take 4 points, A, 1B over here, C, and then D. Okay. Now, from here we have to join them to make lines which are going to determine what I have to choose and what intersections I have to consider. Fine. Okay. Now, what we're getting over here is that if you join, let's say, AB and CD, let's keep D a little close over here. So CD and AB, at some point, not at infinity, but at some point, at certain distance, you will see that they're going to converge and there'll be one point of intersection which we'll consider. Okay, so this is just for A, B and C and D. To find the total number of cases, what we can do is, we'll have to multiply and use the combinational approach. Okay, so total number of ways will be, I will select one point out of the M. For example, here I selected A, and then I select one point on B, which will be NC1, and similarly I will select one point from the remaining, which is M minus 1 C1, and I'll select one more point from the remaining, which will be N minus 1 C1, so that I can make these 4 points and then consequently, subsequently look at how I can get the total number of points of intersection. But there's a catch to this method which we have written over here. Let's say in MC1 we have considered the point A, this is on L1. In NC1 we considered B, this is on L2. M minus 1 C1 we considered C, and over here we considered D. For this set which we have considered over here, let's say I could have taken MC1, and in this MC1 let's say I could have taken C, and let's say for this B or NC1 I would have taken D instead of B over here, and then I would have taken A and B. Now, for both these sets of understanding, whether I take A, B, C, D or C, D, A, B, it's going to have the same point of intersection, which is going to be somewhere around here. Right? They're going to merge over here. That means I'll have to halve this entire expression to determine the total number of lines or points of intersection I can come up with so as to suffice for the condition given in the problem. So the answer by one method, I'll be discussing the second method right now. One method can be this MC1 into NC1 into M minus 1 C1 into N minus 1 C1. So if we take the half outside, then we'll be getting M factorial by M minus 1 factorial into N factorial by N minus 1 factorial into N minus 1 whole factorial, N minus 1 whole factorial by M minus 2 whole factorial into N minus 1 whole factorial by N minus 2 whole factorial. You can see that this will be cancelled out with this. M factorial by M minus 2 factorial can be written as M into N minus 1, and similarly N factorial into N minus 2 whole factorial can be written as N into N minus 1. So you'll get half into M into M minus 1 into N into N minus 1, which can be given as half into Mn separated M minus 1 into N minus 1. There's another way in which we can consider selecting this and proving this answer. Okay, now in this methodology, let's say we have taken one line like this, one line like this, same method, where we have L1 with M points, and L2 with n points. Okay. Now, what we would like to do over here is that I want to select any 2 points. Okay. Let's say I take the same set of points A, C, let's say B and D. Okay. Now let me say that I am directly choosing 2 points from the line containing m points and the line containing m points. So it will be MC2 into NC2. However, let's say I have taken AC and BD. One set of lines, so let's say that D is somewhere over here and C is somewhere over here. One set of lines I can say is AB. So one set of lines can be connecting AB and CD, which will merge somewhere over here. But if I'm selecting these 2 points from each of these lines, then I can also take AD and BC, AD and CD rather, which means these line in itself will be intersecting at another point. So for the same set which I have taken, MC2 into NC2, there will be 2 observations to note. So I will do this whole multiplied by 2. Therefore, we will be getting m factorial by m minus 2 whole factorial, 2 factorial, into n factorial by n minus 2 whole factorial, 2 factorial, into 2. So we can cancel out 1 2 factorial with the 2 because 2 factorial is also equal to 2. M factorial to n factorial. So we can write this again as m into m minus 1 by 2 into n into n minus 1, which will give us the same observation which we have come to, that is half into mn into m minus 1 multiplied by n minus 1. So this is how we can prove that if we have straight lines having m points and n points, then when we will take their intersections, there will be half into mn into m minus 1 into n minus 1 points to consider, which will occur when there will be an intersection between them. Now the last 2 questions. So this is a video which we have with the kind of elementary questions. The last question though required a little bit of thinking, but these were elementary questions which we were discussing, and the next 2 questions have to be dealt with a lot of consideration and carefulness, because these are concepts that will have to be carried beyond the Olympiad level, even in universities and degrees, where graduation, undergraduation, post-graduation, all these levels will be considering the next 2 problems because they're very difficult and complex. However, they are intriguing to understand in the same statement, and we'll be taking them in the next video because they require that much of deliberation and understanding. Thank you.